Hello students, this is Latif sir. In this video, I am going to start the chapter 6 of class 8 chemistry. The topic is chemical reaction. Chemical reactions, this is the topic. So first you have to know what is a chemical reaction. It is also called as a chemical change. Okay, chemical reaction is also called as a chemical change. Okay, so chemical reaction is one type of change that takes place when elements or compound when one or more elements or compounds react with each other under different conditions to form one or more new substance, that is one or more new products, is known as chemical reaction. Okay, so what is a chemical change? A chemical reaction, it is a change that take place when one or more element or compounds react with each other under different conditions to form new product. Okay, and the symbolic representation of a chemical reaction, that is representation of a chemical reaction using the symbol and formula of the reactants and product is known as chemical equation. Okay, so the substances that are undergoing in the chemical change are known as reactant, and the substances that are produced after the reaction are known as products. Okay. So a chemical reaction is represented by a chemical equation, and generally in a chemical equation reactants are written on the left hand side of the chemical equation, and the products are written on the right hand side of the equation. Okay, and the reactants and product are separated by an arrow. Okay, reactants and products are separated by an arrow. Reactants are on left hand side, and products are on right hand side. You have to write this is the, and you have to give a positive sign, plus sign, between two reactants or between two products. Okay, this is the representation of a chemical equation. And in previous chapter you have already studied that how to balance a chemical equation, and have told that a chemical equation can be balanced using the atomic theory and law of conservation of mass. Balanced chemical equation means number of atoms of each element present on the left hand side of a chemical equation must be equal to the number of atoms of each element present on the right hand side. This is the balanced equation. Okay, in a balanced chemical equation, number of atom of each element must be equal to number of atoms of each element must be equal in on both side of the chemical equation. Okay, that is, the number of atoms of each element present on the left hand side of a chemical equation must be equal to number of atoms of each element present on the right hand side. Okay, so a chemical equation can only correctly represent a chemical reaction if it is balanced. So balanced chemical equation is most important representation of a chemical reaction. Now see characteristic of a chemical reaction. What are the characteristics of chemical reaction? There are many characteristics of a chemical reaction, like evolution of gas, change in color of formation of precipitate, change in state of reactor and product, and change in energy. These are important characteristics of a chemical change. Okay, and a chemical reaction may show any one of these characteristics. Any one characteristic can show by chemical reaction. So first characteristic is evolution of gas, that is formation of gas during the chemical reaction. Gas is evolved in certain chemical reaction, and the formation of gas in the chemical reaction is indicated as bubble if the reaction is taking place in liquid medium, and the evolution of gas in the form of bubbles, that is evolution of gas within the liquid in the form of bubble, is known as effervescence. Okay, so what is effervescence? Effervescence is the formation of gas inside the liquid in the form of bubble, is known as effervescence. Okay, so in certain chemical reaction gas is formed. For example, when sodium metal reacts with hydrochloric acid, sodium means Na and hydrochloric acid means HCl, it will produce sodium chloride and hydrogen gas. Okay, and the formation of gas is indicated by an upward arrow. Okay, upward arrow, this is the upward arrow. Beside the formula of the gas you have to give an upward arrow to represent the formation of gas in the liquid in the reaction. So when sodium react with hydrochloric acid, it forms sodium chloride and hydrogen gas. Okay, similarly when magnesium Mg reacts with sulfuric acid, that is H2SO4, you will get magnesium sulfate and hydrogen gas. Okay, so in some chemical reaction gas is formed. Next characteristic of a chemical reaction is change in color during the chemical reaction. Change in color. Certain chemical reaction occurs as a result. Certain chemical reactions result in a change in the color of the reactants. Okay, so there are some chemical reaction in which color change takes place. For example, when green colored copper carbonate is heated, CuCO3 is copper carbonate, is heated, you will get copper oxide, black colored copper oxide and carbon dioxide gas. So in this reaction color change takes place. Okay, so when green colored copper carbonate is heated, you will get black colored copper oxide and carbon dioxide gas. So in certain chemical reaction color change takes place. Next characteristic is formation of precipitate during the chemical reaction. Formation of precipitate. So first you have to know what is a precipitate. You have already studied in class 7. A precipitate is a insoluble solid product formed during the chemical reaction. So insoluble solid product formed during a chemical reaction is known as precipitate, and in certain chemical reaction a precipitate is produced, and the formation of precipitate is indicated by a downward arrow. Okay, the formation of precipitate is represented or indicated by a downward arrow like this. Here it is showing. For example, when ferric chloride FeCl3 ferric chloride reacts with sodium hydroxide, that is NaOH, ferric chloride solution is reacts with sodium hydroxide solution, you will get a reddish brown precipitate due to formation of ferric hydroxide FeOH whole thrice. This is a precipitate. Okay, and it is formed when ferric chloride reacts with sodium hydroxide solution, and sodium chloride is the another product, sodium chloride. So in this reaction you will get a reddish brown precipitate of ferric hydroxide. Okay, so in certain chemical reaction a precipitate is formed. One more example is given here. Okay, and next characteristic of a chemical reaction is change in state. In certain chemical reaction physical state of reactant changes. For example, when hydrogen gas and oxygen gas combine to form water. In this reaction, two gases combine together, that is both hydrogen H2 and O2, both hydrogen and oxygen are in gaseous state. They combine together to form water, and water is in liquid state. So in this reaction, physical state of reactant changes. Okay, one more example. When ammonia gas reacts with hydrogen chloride gas, it will produce ammonium chloride, which is a solid. Okay, so by combination of two gases in this reaction, a solid is formed, solid ammonium chloride. Okay, a dense white fumes of ammonium chloride is formed in this reaction when ammonia is reacts when ammonia is reacted with hydrogen chloride gas. Ammonia gas plus hydrogen chloride gas, that is HCl. NH3 plus HCl implies NH4Cl. Okay, next characteristic is change in color, change in energy. Change in energy. Based on energy change, there are two types of chemical reaction, exothermic and endothermic. So energy change, there are many reactions that are accompanied by a change in change of energy, by a change of energy. And this change of energy is usually in the form of absorption of heat or release of heat. In some chemical reaction, absorption of heat takes place, and in some chemical reaction, release of heat takes place. Okay, for example, when paper, wood, coal is burned, they undergo exothermic reaction, and release a large amount of heat. Burning of a substance in air, that is burning of a substance in presence of oxygen at high temperature with the release of large amount of heat and energy, is known as combustion reaction. Combustion reaction means burning of a substance in presence of air or oxygen to produce large amount of uh, heat and light, is known as combustion reaction. Okay, so for example, when carbon react with oxygen, it will produce carbon dioxide and heat. Okay, this is an example of exothermic change. One more example is given. When magnesium reacts with oxygen, it will produce magnesium oxide and heat. Okay. And dissolution of ammonium chloride in water is an example of endothermic reaction. Endothermic reaction means heat absorbed in this reaction. Okay, when ammonium chloride, that is NH4Cl, is dissolved in water, in this process heat is absorbed. Okay, heat is absorbed. So this reaction is an example of endothermic change. Okay, ammonium chloride dissolved in water to give ammonium hydroxide and hydrogen chloride. Okay, similarly, photosynthesis is an example of endothermic change. In photosynthesis reaction, carbon dioxide and water combine to give glucose and oxygen, and this reaction energy is absorbed, okay, in the form of light. And respiration is an example of exothermic change. Okay. So these are some characteristic of a chemical reaction. Now the conditions for a chemical reaction. There are many conditions. Okay, for a chemical change to take place, the following conditions are required, like close contact. Most important conditions, close contact. You have already studied in class 7. Close contact. For a chemical reaction to take place, reactants need to come in contact with each other. So close contact is most important conditions for a chemical reaction. Okay, so conditions for a chemical reaction. For example, when ammonia gas come in contact with hydrogen chloride gas, it will produce solid ammonium chloride. Okay, so close contact is most important conditions for a chemical reaction. Second condition is physical state of the reactant. Physical state of reactant. Certain substances react when they are in the solution state. Okay, when the all the reactants are in same phase, that is when all the reactants are in solution phase, okay, or in gaseous phase. So certain substances react when they are in solution state. For example, sodium chloride solution when reacts or when mixed with silver nitrate solution, aqueous solution of sodium chloride NaCl reacts with aqueous solution of silver nitrate, you will get a white precipitate of silver chloride AgCl and sodium nitrate NaNO3. So the reaction is NaCl plus NaCl in aqueous solution, so Aq within bracket Aq plus silver nitrate within bracket Aq. So NaCl solution plus silver nitrate solution to give AgCl, silver white precipitate of AgCl and sodium nitrate. Okay, and this reaction takes place only when both sodium chloride and silver nitrate in the solution form. Okay, but if silver nitrate is in solid state, the reaction does not take place. Okay, so solution form is also important condition. Next, surface area of the reactant. Next condition is surface area of the reactant. Larger the surface area of the reactants, higher is the speed of the reaction. Larger the surface area of the reactant, higher is the speed of the reaction. For example, if we try to dissolve some lumps of sugar in water and some powdered sugar in water, we will observe that powdered sugar dissolve faster than a lump of sugar. This is because the surface area of powdered sugar is much more than lump of sugar. Okay. Similarly, if zinc metal and zinc shavings, that is zinc granules, are added to dilute hydrochloric acid, the zinc shavings react faster and produce more hydrogen than zinc metal. This is because the surface area of zinc shavings are much more than surface area of zinc metal. Okay, so the larger the surface area, higher is the speed of the reaction. So surface area is the important conditions. Next condition is heat energy. Supply of energy is an important conditions for a chemical reaction. Heat energy, especially for endothermic chemical reaction. Okay, so endothermic reactions occur when heat energy is supplied to them. For example, copper reacts with concentrated sulfuric acid when heated. Copper, that is Cu plus H2SO4 sulfuric acid, implies arrow to give CuSO4 plus SO2 plus water. And this reaction takes place only when the mixture, that is copper and sulfuric acid, is heated. Okay. Similarly, iron sulfide FeS is formed when iron is heated with sulfur. Okay, so heat energy, supply of heat energy is important conditions for endothermic chemical reaction. Okay. Next condition is light energy, supply of energy in the form of light. Supply of energy in the form of light. Certain chemical reactions occur in the presence of light, and such reactions are known as photochemical reactions. Okay, so for photochemical reaction, light energy is very important conditions. Okay, so chemical reaction that occur in presence of light are known as photochemical reaction. For example, photosynthesis is a good example of photochemical reaction. Photosynthesis. In this process, carbon dioxide gas combine with water in presence of sunlight only to give glucose and oxygen. So this reaction, photosynthesis, is an example of photochemical reaction that take place only in the presence of sunlight. Okay, so light energy is also important conditions. And next condition is electricity or electrical energy. Electricity. Some chemical reactions occur on passing electricity through them, and such reactions are known as electrochemical reaction. Electrochemical reaction. Some chemical reactions occur on passing electricity through them, and such reactions are known as electrochemical reaction. For example, water decomposes into hydrogen gas and oxygen gas when electricity is passed through water. Okay, so water to H2O to H2 plus O2. Now, decomposition of water is an example of electrochemical reaction which take place only in presence of electric current. When electric current is passed through water, water decomposes to give hydrogen gas and oxygen gas. Okay, and next condition is pressure. Pressure is also important for some chemical reaction. Application of high pressure is important for some chemical reaction. Okay, so for the synthesis of, for example, for the synthesis of ammonia, in this reaction 200 atm very high pressure is required. Okay, in this reaction nitrogen gas combined with hydrogen gas in presence of 200 atm pressure, very high pressure, to give ammonia gas. Okay, so in this reaction pressure is important, very important. When ammonia is formed from hydrogen and nitrogen, 200 atm pressure is required. Okay, similarly carbon dioxide gas is dissolved in water at very high pressure. Okay, in presence of very high pressure carbon dioxide gas dissolved in water to give carbonic acid solution. Okay, and catalyst is also important conditions. You know, catalysts are chemical substances that can speed up or slow down the chemical reaction. Catalysts are chemical substances that can speed up or slow down the rate of the chemical reaction. Okay, so definition of catalyst is given here. Okay, so some chemical reactions requires a catalyst to undergo a chemical reaction at lower energy and in less time. And catalysts are two types: positive catalyst. Positive catalyst can speed up the rate of reaction. Okay, so positive catalyst increases the speed of the chemical reaction. For example, in the preparation of ammonia from nitrogen and hydrogen, iron is used as catalyst, as positive catalyst. In the preparation of ammonia from nitrogen and hydrogen gas, iron is used as positive catalyst. And the substances that increases the effectiveness of the catalyst are known as promoters. Okay, so promoters are chemical substance that activates the activity of catalyst. For example, molybdenum act as promoter for iron in the manufacturing of ammonia by Haber-Bosch process. Okay, in the preparation of ammonia from hydrogen and nitrogen using Haber-Bosch process, iron is used as catalyst and molybdenum is used as promoter. Similarly, manganese dioxide act as positive catalyst in the decomposition of hydrogen peroxide to give water and oxygen, and negative catalyst that decreases the speed of chemical reaction. Negative catalyst, for example, phosphoric acid is used as negative catalyst in the decomposition of hydrogen peroxide to water and oxygen. Hydrogen peroxide to water and oxygen. Okay, and the chemical substance which slow down the activity of a negative catalyst of a catalyst is known as inhibitors are chemical substances that slow down the activity of catalyst. Okay, and enzyme enzymes are biocatalysts similar to catalyst. Biocatalyst, that is catalyst produced in our body. Okay, so enzymes are defined as the biocatalysts which speed up the chemical reaction in the body without getting consumed. There are many biocatalysts. These are also called enzyme, like amylase, pepsin, lipase. These are biocatalysts. Okay, amylase converts carbohydrate to glucose. Pepsin converts protein into amino acid, and lipase convert fat to fatty acid. Okay, so these are conditions for a chemical reaction, and types of chemical reaction I will discuss in next class. Okay, thank you, students.